Okay, so you've solved system of equations, maybe you're using graphing, substitution, elimination, but there's this weird concept of how to classify a system of equations. And all that is really how are you going to describe the solution that you get? So there's two types of solutions that you can get with solving a system of equations. The first one is consistent. A consistent system of equations means it has solutions. So this means it has solutions. Maybe it's one, maybe it's many. The other part could be that it's inconsistent. Inconsistent means no solutions. So how does this come about? So let's talk about inconsistent first, because that is, again, there's only one type of system that this happens. So you solve a system of equations, you get to the end, and you get an untrue statement. Say it says 3 equals 0. That is obviously false. Again, all the variables cancel out. This is telling you that the system is inconsistent or it has no solution. If we think about this a little bit more graphically, all this means is we have parallel lines. And if you analyze the equations a little bit more, look at them in slope-intercept form, maybe standard form, you're going to see that the slopes are the same, but yet they have different y-intercepts, okay? So inconsistent is pretty easy to spot. Parallel lines, same slope, different y-intercepts. Now what about consistent? Well, consistent has two possibilities. A consistent system can be independent or dependent. Independent is what you have probably seen the majority of the time you're solving a system of equations. It is when you solve it and you get one solution. One solution, which is represented by an ordered pair, typically x comma y. Very simply, when you have an xy coordinate plane, you may graph a line and you graph the other, and they intersect at exactly one point represented by a coordinate. And again, this system here, when you get one coordinate as your solution, the classification would be consistent, independent. A dependent system is when it's going to similarly fall like something like this, except you go through the process of solving and you see you get something like 0 equals 0. That is a true statement. Or maybe it's 3 equals 3. It is a true statement. That means that there's infinitely many solutions, because it typically would represent, if you would look at it in slope-intercept form or in standard form, it's going to be the same line, just represented with different variables. For example, with different coefficients. For instance, it could be x plus 2y equal to 3, and the other system could be 2x plus 4y equals 6. Notice that these two, if I divided this bottom one by 2, it's the same exact equation. So anytime we augment a linear by multiplying it by the same coefficient, you're going to have the same line. So again, 3 different ways to classify a system of equations. Most common, what you see is consistent, independent, again, one solution, x comma y. However, if there is something strange going on that you notice, okay, my variables all canceled out, well then what happened? Is it a true statement? Well, that just means it's infinitely many. It's the same line. Or maybe it's a false statement, which is inconsistent, no solution, we have parallel lines. I hope that you find that helpful. Please let me know if you have any questions on that topic.